No, this video is about power. Okay, and we're also going to do some examples, worked examples on the previous topics of energy and work done we have covered. So, to start off with this video, what is power? Now, consider two cars going up a hill. Okay, the both cars are exactly identical. They are both exactly the same weight. The force of gravity is, they are working against the force of gravity going up the hill. Now, which car has greater power? Well, the power depends on how fast the work is done. They're doing work against gravity. The one that does the work faster, the one that gets there first, is the one that has got greater power. So we define the power as work done divided by time. Now, work done is measured in joules, the time is measured in seconds. So the power is measured in joules per second or watt. Now, if something can work at a rate of 1 joule every second, the power of that is 1 watt. 1 kilowatt, kW stands for kilowatt, equals 1000 watt. 1 megawatt is 1 million watts. Now, we use these subscripts, like, for example, the power of a power station is so many megawatts. Okay, we use megawatts, even gigawatts. Okay, now an interesting experiment would be that if you wanted to measure your own power, you can do this experiment. If you run up the stairs, okay, to a height of, and you know how much the height of the stairs is, and you time yourself how long it takes you to move, and you're carrying your own weight. Okay, you have to know your weight in kilogram or mass in kilogram. Then you can work out how much your power is. So I've illustrated this with an example. A man of mass 70 kilogram runs up the stairs through a vertical height of 8 meters, and it takes 10 seconds to do this. Okay, what is his power? Now, first of all, we have to find the force. Force is his weight. W equals m times g. It's mass times gravity. Now remember, gravity is 10 newtons per kilogram. It's 9.8, or we approximate it to 10 to make the calculation easier. So weight equals, his mass is 70 times g is 10, which is 700 Newton. So he is working, he's lifting his own weight when he's going up. So he's working against the force of gravity, which is 700 Newton. And we say, how much work does he do? Work done in moving up the stairs. The stair has a height of 8 meters. This is 8 meters. His mass is 70 kilogram. So it's 8 meters, and it takes 10 seconds to do that. So work done equals force multiplied by the distance moved in the direction of the force. Force is 700 Newton. That's his own weight, times by 8 meters, which is 5,600 or 5,600 joules. So he does a work of 5,600 joules in moving up 8 meters. And how long does it take to do that? It takes 10 seconds. So his power is going to be equal to work done divided by the time. Work done is 5,600 joules divided by the time. It takes 10 seconds, which is 560 watts. So he develops a power of 560 watts. in other words, he can work at a rate of 560 joules every second. Right. So the next thing that we're going to talk about is summarize what we've done in this section on work, energy, power, and do some examples, worked examples, to show you this, to illustrate. No, I've got an example. I hope you can see clearly from this. I'll put this one down here. So we have a car is traveling at 30 meters per second against a force of 600 Newton, which is the opposing force. Okay, it could be force of friction, could be force of gravity and friction combined together. Now, how far does the car go in 10 seconds? And B, how much does the car engine work in this time? Okay, we will take one question at a time. Let's start off with A. A car is traveling at 30 meters per second. How far does it go in 10 seconds? So we use the formula, speed equals distance. Speed equals distance divided by time. Now, if you remember, we've done the formula triangle. Distance goes on top, speed times time. So if you want to find the speed, it's distance divided by time. If you want to find the distance, it's speed times time. So we said distance equals speed times time. The speed is 30 meters per second, and the time it takes is 10 seconds. 30 times 10 is 300 meters. So he travels a distance of 300 meters. Okay, that's the answer to the first one. Part B, what is his power? What is the power the car is developing? Remember, power equals work done divided by time. Okay, before we find the power, okay, we write down the work done by the car. How much work does the car do in moving this much distance against a force of 600 Newton? So work done, remember, is force multiplied by the distance. The force, the opposing force is 600 Newton. Okay, so the car is overcoming a force of 600 Newton and it's traveling a distance of 300 meters. Okay, we worked out the distance, how far it travels in 10 seconds. 6 times 3 is 18. 18 with 4 zeros, 180,000. 180,000 joules. So it does a work of 180,000 joules. And how much power does it develop? Power equals, now remember the formula for power? We've just recently done that. Power is work done divided by the time. That's the work done divided by time. So it does work of 180,000 joules and it takes 10 seconds to do that. So that's 180,000 divided by 10, which is 18,000 watts. And if you divide that by 1,000, that you can turn that into kilowatts, which is equal to 18 kilowatts. Okay, so the power is 18 kilowatts. Okay, part D, C. No, actually, this was part B was how much does the engine work? So that's the work done is B, and this is part C. So part B is, this is how much the work the engine does, okay, and this is the power. And then part D is burning petrol supplies 60 kilojoules of energy per second. Now this is the key word, per second. So if it's 60 kilojoules, that means 60,000 joules every second. In other words, 60,000 joules divided by 1 second is equal to 60,000 watts. No, remember, joules per second is watts. So in fact, it's got a power of 60,000 or 60 kilowatts, okay, or 60,000 watts. And our answer is coming to 18 kilowatts. Now, why is there a discrepancy? Okay, it's using that much fuel, it's burning that much fuel, but it's only getting 18 kilowatts out of it. The reason is, it says, why is your answer to part C smaller than this value? The answer is smaller because a lot of the power is wasted as heat or due to friction and air resistance. So answer to part C is small because power is wasted due to friction and air resistance or air drag. Okay, so that is why you can never get efficiency of 100%. Okay, power is always wasted as heat or as due to friction. Now part E, what is the efficiency? Okay, I'm going to rub this bit out and write the efficiency up here. Now efficiency Now, remember percentage efficiency, the formula is, we say that the power output divided by the power input times by 100. Okay. Now, efficiency can be energy output over energy input times by 100. It can be work done, work output divided by the work input times by 100. Okay, so the power that we're getting out of this is 18 kilowatts. Okay, we can use the kilowatts in this. 60,000 watt is 60 kilowatts. Okay, now this is 60 kilowatts. So we are getting only 18 kilowatts out of the 60 kilowatt of power that we are supplying due to fuel. Okay, which is 60 divided by 60. The power that we're putting in is 60. The power we're getting out is only 18. Times that by 100. 6 3s are 18. That gives you 30%. So the efficiency of this is only 30%. Only 30% of the energy of the petrol is actually being used in driving the car. All the rest is just wasted as heat, air resistance, and so on. Okay, this is the end of this video.